So many of you are working diligently on your C++ review videos, and that's good. And so we're nearing the end of the first week of the course, and we haven't really talked too much about data structures yet. So I wanted to actually maybe begin at least a high-level discussion of those. They're fairly simple. Once you actually start to get into the code, it gets a little more complicated, but just understanding it from a high level, you've actually probably encountered these data structures in your daily life. So the three types of data structures that we'll be working with will be stacks, queues, and trees. And we have a sort of outlier here a little bit, and that is what are known as classes. And classes are unique because stacks, queues, and trees you'll see in all programming languages. Classes are specific to object-oriented languages. So we won't discuss classes today. Just know that's one of the topics that we'll be covering in the course. So let's go through stacks, queues, and trees today. So what is a stack? Imagine you have a stack of paper on your desk, and we'll write the paper kind of thick here. So imagine that's from a side view, a bunch of paper. It's really, really thick paper, but you get the idea. Otherwise, it would be difficult to see. It would just look like one blob. And so you walk over, and if you need a piece of paper, it's blank paper, it's writing paper, you walk over and you take one from the top of the stack. And say you go out and you buy a new pack of paper, you open the package, you generally put the new paper on the top. So you take from the top and you remove from the top. And so there's a specific name for that, and that is called LIFO. Last in, first out. So as the name suggests, the last one you put in is the first one you take out. So I hope that makes sense, and you've encountered stacks in your daily life. If you have a stack of CDs and you of blank CDs, if you have a stack of paper, a stack of cards, a stack of books, and that's where the name really comes from. So let's move on to queues, which are very similar, except for you take from the other end. So let's talk about the easiest example you've probably encountered in your daily life, which is probably the grocery store. And you've got somebody working at the grocery store that sits behind the counter, and then you've got people that take their groceries to that person to check out, and as they get in line, they enter the queue. And so as a new person comes in, they go to the end of the queue, and then people are serviced based on the time they entered the queue. So a new person comes in, and then so you can see this person serviced first, this person serviced next, and then that person. And so that's sort of the opposite, and so the name for that one is a FIFO. And sometimes you'll hear it called a FIFO queue. So the first one in is the first one out. So in this case, the last one to enter was the first one to leave. In this case, the first one to enter is the first one to leave. So I don't want to overcomplicate that. This is just really high level, and actually will get a little more tricky as we actually try to code it, as everything usually does. But hopefully you can understand that at least from an intuitive level. And for any of you who've traveled outside of the country, you'll hear in England they actually call a line at the grocery store a queue. They don't call it a line like we do. They actually do call it a queue. And so next we go to tree structures, and trees are slightly different. So the way a tree works is you have nodes, and then we will be working with specifically a type of tree. I made this a little long. A type of tree called a binary tree. And so what happens is you have a parent, and these are known as children. And then they have these little paths, and eventually you reach a point where you have an endpoint with no more children, and that's called a leaf. And leaves can occur anywhere. They don't have to balance in any sort of way. So we could have a leaf on the left-hand side there that looks like that, and then something like that, and then something like that, and then it just goes back and forth. So hopefully you get the idea that these can be drawn in many different configurations, and you can probably think about this as maybe your children. So you've got a person, and let's pretend that people only have 1 or 2 children. Let's pretend this is a place where that's some restriction. You can only have at most 2 children, and so that person has their children, and then that person has a child, and that person either chose not to have children or hasn't yet, and so you can see it goes through. So get a little comfortable with the terminology, and that these are the parent and the children, and you've got nodes, and then you've got a leaf node where it ends. And we'll leave out classes for now, because classes are kind of a little bit of an outlier. They're a little bit different than the other structures that and they're a little bit more difficult to explain, and they map directly back to the programming language. So just for right now, hopefully you get a pretty good sense of stacks, queues, and trees.